So earlier this week we had a homework question from assignment 2.2 where we talked about how if you have the function g of t was equal to 4t squared minus 3t plus 5, and I wanted you to find the value of g of t minus g of 2. For this we did the basic substitution. If you remember, we got the answer 4t squared minus 3t minus 10. What we're going to talk about today first is going to be very similar to that. What we were doing here was we were just subtracting the function g of t from its value, or its evaluated function value of g of 2. When we take a look at this, we can talk about all sorts of function operations here, and when we are adding functions, subtracting functions, multiplying and dividing functions. Adding and subtracting we kind of have already discussed a little bit in class. The big thing we need to be careful here is when we distribute that negative. We want to make sure we're distributing that negative to every single term within the g of x function. When we multiply, we want to make sure that we are either distributing and or foiling the necessary terms here. So if we have like f of x represents a binomial and g of x represents a binomial, in order to find the product of f of x and g of x, we would make sure that we need to FOIL those. Lastly is the division, and the big thing we need to note here is that we obviously, g of x cannot equal 0. We will put that limit on there because we cannot end up with 0 in our denominator. To take a look at a quick example of this, if I'm given the function f of x is equal to 3x plus 2 and g of x is equal to 4 minus 2x, and I want to find the product of the two of them, which I can see here, all I would do is I would rewrite this as f of x times g of x. I'm then just going to do a pure substitution here. I know f of x is equal to 3x plus 2. And for my g of x, I'll keep some colors here the same so we can see, is going to be 4 minus 2x. Now because I will be foiling these, I am going to put these in parentheses. And so all I would do now is just simply FOIL. First times first, I'm going to get 12x. Outside, I get minus 6x squareds. Inside, I get plus 8. And last, I get minus 4x. From here, I'm combining my like terms. So I'm going to get negative 6x squared plus 8x plus 8 as the product of f of g, or f of x times f of g. The next type of problem we're going to take a look at is called the composition of the functions. And a composition of a function is where we are basically combining the two functions so that the output of one function becomes the input of the other function. It is represented as f of g of x. That's how that would read. These are the two different notations that you would see for this. Highlight that for us. These are the two different notations that we would see for it. Order does make a difference here. Down here, I have f of g of x is not the same of g of f of x. So order does make a difference, which one you're inputting for it. So we'll take a look at a quick example to go through here. And if I'm given that f of x is equal to x plus 1 and g of x is equal to 2x, and I want to find f of g of x, I'm going to start by rewriting my f of x function here, or rewriting this in the other way so I can see exactly what I'm substituting. So I'm going to have f of g of x, and then I'm going to substitute in my 2x. Instead of writing g of x, I'm going to write 2x. So I want to find f of 2x. And this is very similar now to the evaluating the functions that we've already done previously. So now, if f of x is equal to x plus 1, and I want to find the value of 2x of that, I would write it as 2x plus 1. And for that, I'm simply just doing the substitution. I'm taking this 2x value and plugging it in wherever I had an x in my f of x function. If I wanted to now find g of f of x, I would start off by stating g of f of x. I'm going to substitute in my f of x by writing g of x plus 1. And now I'm going to take this x plus 1 and I'm going to plug it in to my g of x function 2x. So this now becomes 2 times x plus 1. I can distribute that 2 and get that g of f of x is equal to 2x plus 2. The last thing we're going to talk about is just how we can find the domain of our composite functions. So when we are finding the domain or thinking of defining the domain here, we want to combine the domain of the input function and the domain of our composite answer. So we're taking those two to make one final domain. A quick example I have here to go through this is if I have the function f of x is equal to x over x plus 1 and g of x is equal to 1 over x minus 2. And I want to find the domain of f of g of x. So what I'm going to first do is rewrite this as f of g of x. I can visualize that a little bit better. And I want to start by substituting in my g of x. So that's going to get placed right there. So now I'm finding f of 1 over x minus 2. I'm going to stop right here because this is our first domain. This is going to be our first part of our domain. G of x is our input function. That's the one we are substituting in first. For this one, x cannot be equal to 2. The reason x cannot be equal to 2 here is because if x was equal to 2 and I plugged it in for this, then I would get an undefined or a 0 in my denominator. So that's going to be my first part of my domain. From here I can go through and solve this, and I'm going to find the value of f of 1 over x minus 2 by substituting that 1 over x minus 2 into my f of x function, which is x over x plus 1. So this will become 1 over x minus 2 all divided by 1 over x minus 2 plus 1. From here, if I multiply by my least common denominator, x minus 2, and simplify, I end up getting 1 over 1 plus x minus 2, and that will simplify to 1 over x minus 1. So the next thing I need to do is take a look at my final answer. And here, my limiting factor is that x cannot be equal to 1. If x is equal to 1, then the composite of the functions g of x and f of x will be undefined. So therefore, this is x cannot equal 1. So when I combine my domain of x cannot equal 1 and x cannot equal 2, I could say something like all reals except x cannot equal 1 and x cannot equal 2. So coming up for class, we're going to start to talk more about these, do more example of these, and also move on to inverse functions. Thanks for watching.